Good evening, sir. I'm Dan Ji Kwan from D3. Today, I would like to do a project presentation by using Preemptive SJF to solve this question. We start with 0 millisecond. The process is P2. It runs until 3 millisecond. Then P1 is coming with the burst time of 5 millisecond. We're still running with the P2 with burst time of 4 millisecond because P1 have the burst time if with 5 millisecond that is uh, longer than the P2. Then P2 running uh, running to P running to 4 millisecond. Then P6 is coming in with a burst time of 4 millisecond. P2 is still running to the 6 millisecond. Then P3 is coming in with the burst time of 11 millisecond. Then P2 is running all of this burst time until 7 millisecond. Then we choose another process with the shortest burst time, which is P6 with the burst time of 4 millisecond. Then P6 is run until 8 millisecond. P5 is coming in with the burst time of 2 millisecond. We select the shortest burst time of process, which is P5 with the burst time of 2 millisecond. P5 is run until 9 millisecond. Then P4 is coming in with the burst time of 9 millisecond. We're still running with P5 until it's run all of its burst time. Then after P5, we select the shorter burst time of the remaining process, which is P6. The remaining burst time of P6 is 3. We run all of it until it reach 30 millisecond. Then we find another which is P5 with the burst time of 5 millisecond. We run all of it burst time until 18 millisecond. We find another which is P4 with the burst time of 9 millisecond. We run all of it until 27 millisecond, and the last one is P3 with the burst time of 11 millisecond. The all of the running time is using 38 millisecond. Next, we calculate the waiting time of it. The formula of this calculation is running time minus the arrival time. For P1, its running time is at 30 millisecond minus its arrival time is 3 millisecond. We get the result of 10 millisecond for waiting time. For P2 is running time 0 minus arrival time is 0. For P3, its running time is 27 millisecond minus the arrival time of 6 millisecond. We get 21 millisecond as the waiting time. For P4, the running time is at 18 millisecond minus the arrival time of 9 millisecond. We get 9 millisecond as the waiting time. For P5 is 8 millisecond running time. We minus the arrival time of 8 millisecond. We get 0 for the waiting time. For P6, we use another formula, which is first running time minus arrival time. By using 7 minus 4, we get 3, and plus with the second running time minus the first ending time, which is 10 minus 8. Which one? Yeah, we get 2. After that, we plus 3 plus 2 is equal to 5. 5 is the waiting time for the P6. The average time is total up all of the waiting time divided by the number of process is 6. Then we get the result of 7.5 millisecond. That's all of my project presentation. Thank you.
Hello, sir and everyone. I'm Tan Chun Ho, and I will proceed for the last part for our team. Okay, and I will explain for this method, which is the non-preemptive priority. I use back the sequence question to explain for this. This method, the processor will depend on the process priority to decide and arrange which process will run first. Okay, so the first is process 2 is because the process 2 will arrive at 0 millisecond and the processor can only to run this process first. And because this is a non-preemptive priority, so the processor will not change the process when the more priority process came in. So the first 0 to 7 millisecond is the process 2. Okay, so the next, when the 7 millisecond, the process 1, 3, and 6 already arrived, but this both haven't arrived yet. So the processor will depend on this 3, the priority. So the process 3 is more priority, which is the second priority. So processor will run the process 3, and process 3 will take 11 millisecond burst time. So 11 plus 7 is equal to 18. So process 3, 18 millisecond will end. So the next, actually at the 18 millisecond, all the process already arrived because the latest is the process 4, which is 9 millisecond already arrived. So actually 18 millisecond already arrived already. So we just can ignore this part. We look at this priority part. Okay, so now the process 5 is the first priority, and now it already arrived. So the processor will move to this process 5. And the process 5 will take 2 millisecond burst time. So 2 plus 18 is equal to 20 millisecond. Okay. For this, first priority is done, and the second priority is process 3, which done just now. Process 3, third priority already done, process 2. So the next is the process 4, which will take 9 millisecond burst time. So 20 plus 9 is 29. Process 4 done. The 5 is process 1, and it will take 5 millisecond burst time. 29 plus 5 is equal to 34. Okay, so the last is the process 6, which the priority is the last. Okay, so 24 plus 4 is equal to 28. So the processor process all the process here. So we take a look for the waiting time. How to calculate this waiting time is look at when the process start to process and look at the arrive time. So we look at the first process 1. Process 1 will arrive at 3 millisecond. So, but it will process when 29 millisecond. We start on 29 milliseconds. So 29 minus 3 is equal to 29 minus 3 is for the process 1. 29 minus 3 is equal to 26. So the process 1 waiting time is actually 26. Okay, 29 minus 3 is 26. So for the process 2 is it arrives at 0 millisecond and it start process to when 0 millisecond. So actually there's no waiting time for process 2. And process 3 is start when 7 millisecond. Process 3 arrive at 6 millisecond. So actually it is just waiting for 1 millisecond. Okay, so the process 4 is calculated as just now I mentioned. Same calculation. So this is all the process waiting time. So this waiting time is use the arrive time and the start process time. So start process time minus the arrive time can get a waiting time. So now we calculate for the average waiting time is total up this all and divide with how much it got. This got 6 process, so 26 plus 1 plus 11 plus 10 plus 30 and divide with 6. Okay, so which is 13 millisecond. So that's all for the non-preemptive part. And that's all for our team presentation. Thank you, sir and everyone.
Morning, sir. My name is Wong Xiongyi. Today I will explain about the question and solution for round robin. The quantum is 3. So the first one will be process 1 because arrival time is 0. So it will be the first one. Then at the time from 0 until 3, P5 is coming. P5 is coming, so we run P5. So run P5 and P1 burst time is 3 minus 3 and we get 0, so that P1 is already completed, so we won't put it to the bottom. And after we run P5 at the time from 3 until 6, P4 and P3 is coming. P4 and P3 is coming, so that we put P4 and P3. We run P4. P4 burst time is 12 and we minus 3 we get 9. After we run P4, we put it to the bottom, and at the time from 6 until 9, P2 is arrived. So we add P2 here. After we run P4, we will run P3. P3 burst time is 10. Minus 3 we get and remains 7. After run P3, we will put to the bottom and we run P5. P5 left 5 minus 3 remain 2. After we run P5, put to the bottom and we run P2, which is on the top. We run P2. P2 got 6 minus 3 remains 3. After we run P2, because it is also have the remaining, so we put it to the bottom and we run the top one, which is P4. P4 left 9 minus 3 we get 6. After run P4, put to the bottom and we run the top one, P3. 7 minus 3 we get 4. After that, put to the bottom and we run P5. P5 remaining 2 and minus 2, and we get 0, so that it is already completed. After that, we run P2. P2 remaining 3 and minus 3 and also get 0, so it is already completed. Then we run P4. P4 remaining 6 and minus 3 we get 3. After we run P4, we put to the bottom because it has a remaining. Then we run P3. P3 remains 4 and minus 3 and get 1, so it will put to the bottom. And we run P4. P4 left 3 minus 3 and we get 0, so that it is already completed. So we run the last one, which is process 3, and we get 0. So the total time is 39. The waiting time for process 1 is 0. There is no waiting time because the arrival time of the process 1 is 0 and here is 0. After that, for process 2, 15 and minus 8, and here 21 minus 18, we get 15. Then we calculate the waiting time for process 3, 9 minus 6, and plus 21 minus 12, and plus 32 minus 24, and also 38 minus 35, and we get 23. For process 4, 6 minus the arrival time, and 18 minus 9, 29 minus 21, 35 minus 32, we get 22. And for the last one, process 5, 3 minus 3, and 12, 12 minus 6, and 24 minus 15, and we get 12. The average waiting time is the sum of the waiting time divided with 5, and we get 15. That's all from me. Thank you.
Good afternoon to my lecturer, Mr. Johnson Bao. My name is Hugh Jian for OS4L. Today I'm going to present the priority for our group assignment. Firstly, the preemptive priority starts with P1 because the arrival time is 0. Then the P5 is incoming with 3 milliseconds. Then P5 also incoming with 4 milliseconds. Because the priority of P5 is bigger than P4. Then P3 is incoming with 6 milliseconds to the preemptive priority. Then P3 also incoming with 8 milliseconds to the preemptive priority because the priority of P3 is bigger than P2. Then the P3 is incoming with 16 milliseconds because the P3 has the 10 burst time and he left the 2 milliseconds. Then 10 minus 2 is 8. X plus X is 16. Then the P2 is incoming with 20 milliseconds because the P2 has burst time has the 6 milliseconds. Then the 60 plus 6 is 22. Then after that, P5 is incoming with 27 milliseconds into the preemptive priority because the P5 has left 5 milliseconds in the P5. Then 22 minus 5 is 27. Then lastly, the P4 is incoming with 39 milliseconds. This is because the 27 is plus with 20. Then we get the answer with the last answer is 39. The waiting time, the solution waiting time is running time minus with arrival time. Then the average waiting time is waiting time divided by 5 process. Okay, thank you.